Did you know that almost everything you think you understand about the cosmos is wrapped in beautiful, seductive lies? Not malicious deceptions, but myths so elegantly simple that they've become more real than reality itself. The universe doesn't care about our need for easy answers. Today, I'll reveal the 15 most persistent myths about space. Misconceptions so deeply embedded in our culture that even mentioning them feels like heresy. From the color of stars to the nature of darkness itself, these aren't minor details. They're fundamental misunderstandings about the very fabric of existence beyond our atmosphere. What few know is that some of these myths were deliberately crafted by scientists who thought the truth too complex for public consumption. The final revelation, number 1, concerns something you see every single night. Something so familiar, you'd swear you know it intimately. You don't. What you think you're seeing is an optical conspiracy, a trick of biology and distance that's been fooling humanity since we first looked up. Stay to the end, because what I'll reveal about the night sky will fundamentally change how you perceive reality itself every time darkness falls. Let's begin. Number 15. The sun is yellow. Imagine standing beneath what you believe is a yellow star. Your entire civilization built on this chromatic certainty. Every child's drawing, every flag, every cultural representation, golden yellow. It's so fundamental that questioning it feels absurd. The sun is white, pure, brilliant white, a perfect fusion furnace emitting nearly equal intensities across the entire visible spectrum. The sun is a G-type main sequence star with a surface temperature of 5,778 Kelvin, which corresponds to white light emission. So why the deception? Earth's atmosphere scatters shorter wavelengths of light more efficiently than longer ones. This strips away blue and violet wavelengths, leaving yellow, orange, and red to dominate what reaches our eyes. Ancient civilizations observed this atmospheric filtering and concluded the sun itself was yellow. Astronauts who've seen the sun from orbit describe it as intensely white, almost painfully so. They return with cognitive dissonance, the feeling that they'd somehow traveled to a different solar system, but they hadn't moved anywhere. They'd simply seen clearly for the first time. That's the sun, not a golden god, but a white furnace, misunderstood by every human who ever lived beneath an atmosphere. Number 14. Space is a perfect vacuum. Picture absolute nothingness, a void so complete that not a single atom drifts through the darkness. Space, we're told, is empty. Space is not empty. The interstellar medium contains approximately 1 atom per cubic centimeter. That sounds sparse, but spread across cosmic volumes, it adds up to more matter than exists in all the stars and galaxies combined when you account for total volume. But atoms are just the beginning. Space teems with radiation, cosmic microwave background, radio waves from quasars, X-rays from black holes. Then there are cosmic rays, high-energy particles sleeting through space constantly, penetrating spacecraft hulls. Apollo astronauts reported seeing flashes even with eyes closed, cosmic rays striking their retinas directly. Modern quantum field theory reveals that even perfect vacuum seethes with virtual particles, quantum fluctuations that pop into existence before annihilating. These create measurable effects, like the Casimir force. Space isn't empty. It's a thin soup of matter, energy, and possibly realities we haven't yet discovered, masquerading as nothing. Number 13. The moon has a dark side. Imagine a hemisphere of eternal darkness, forever turned away from Earth and the Sun itself. Pink Floyd wrote songs about it. We speak of the dark side of the moon as if it's a place of permanent shadow. The moon has no dark side. It has a far side, a hemisphere we never see from Earth. But this receives exactly as much sunlight as the near side, just at different times. When we see a new moon, the far side is fully illuminated. When we see a full moon, the far side is completely dark. The term dark side originated from linguistic convenience and romantic imagination. Before Luna 3 photographed it in 1959, the far side was unknown, mysterious, dark, in the sense of unexplored rather than unilluminated. What few know is that the far side serves an extraordinary purpose. It's the quietest place in the solar system for radio astronomy. The moon's bulk blocks all radio emissions from Earth, offering a pristine electromagnetic environment. That's the moon's far side, not shrouded in eternal darkness, but rotating through the same cycle of day and night we experience, just hidden by celestial mechanics. Number 12. You'd explode in space without a spacesuit. Picture the horror movie scene. An astronaut exposed to vacuum, their body swelling grotesquely before exploding. It's cinema's favorite space death. Sudden, violent, spectacular. You would not explode in space. Human bodies aren't balloons. Skin and muscle contain internal pressure just fine. In 1966, a NASA technician's suit depressurized in a vacuum chamber. He remained conscious for 14 seconds before losing consciousness, was repressurized within 90 seconds, and recovered completely with no permanent injuries. What actually happens is subtler, but still horrifying. Air in your lungs would expand. You must exhale, not hold your breath. Water on exposed surfaces would boil at body temperature due to zero pressure. You'd lose consciousness within 15 seconds as oxygen-depleted blood reached your brain. Death would follow in about 2 minutes from asphyxiation, not explosive decompression. The explosive decompression myth actually makes space seem safer, suggesting death is quick and painless. The reality is worse: slow suffocation while remaining conscious, possibly for a full minute. Space doesn't make you explode. It makes you suffocate slowly while water on your eyes boils away. Number 11. Mercury is the hottest planet. Imagine standing on a world so close to the sun that the ground glows red hot. Mercury, first planet, closest to our star, surely the hottest place in the solar system. Proximity equals heat, except Venus is hotter. Mercury's maximum temperature reaches 430 degrees Celsius, but Venus maintains 465 degrees Celsius consistently across its entire surface, day and night. Venus is hotter than Mercury, always, everywhere, without exception. The reason is atmosphere. Mercury barely has one, just a thin exosphere holding no heat. Temperatures plummet to minus 180 degrees Celsius at night, creating a 600-degree swing. Venus is wrapped in atmosphere 92 times denser than Earth's, creating a runaway greenhouse effect so extreme it resembles hell. Soviet probes that landed on Venus survived only 23 to 127 minutes before succumbing. Venus likely once had liquid water oceans, but received just enough extra solar radiation to trigger a feedback loop. Warming caused evaporation. Water vapor caused more warming, until the oceans boiled away completely. Venus is the hottest planet, not despite being farther from the Sun, but because atmospheric composition matters more than distance. Number 10. Asteroid belts are dense, dangerous fields. Imagine threading a spacecraft through tumbling rocks, weaving between boulders the size of mountains. Han Solo dodging asteroids. This is what we imagine when we think of asteroid belts. The reality is heartbreakingly empty. The asteroid belt contains perhaps 2 million asteroids larger than 1 kilometer, distributed across a volume so vast that average spacing becomes 600,000 kilometers, 1.5 times the Earth-Moon distance. If you stood on an asteroid, you wouldn't see others as visible objects. Every single probe sent to the outer planets transited the asteroid belt without incident, without special navigation, without even seeing asteroids unless specifically aimed at one. The misconception originates from the name itself. Belt suggests continuous material. But if you combined all asteroids into a single object, total mass would be only 4% of the Moon's mass. It's not a barrier. It's barely an inconvenience. That's the asteroid belt, not a dense collision hazard, but a nearly empty expanse where rocks too small and too far apart to matter drift in lonely silence. Number 9. The Great Wall of China is visible from space. Picture humanity's greatest monument, visible even from orbit, the Great Wall of China, supposedly the only man-made structure visible from space, even from the Moon. It's taught in schools, cited as evidence of human engineering triumph. It's completely false. From ISS altitude, the Great Wall is essentially invisible to unaided human vision. The wall averages 6 meters wide, a tiny ribbon that blends perfectly with surrounding landscape. Major highways and airport runways are far more visible. Multiple astronauts have directly contradicted the myth. Yang Liwei, China's first astronaut, stated he couldn't see it. Neil Armstrong and Chris Hadfield confirmed the wall is not visible without aid. From the Moon, 384,400 kilometers away, the entire Earth appears marble-sized. The idea that a wall less than 10 meters wide could be distinguished is mathematically absurd. At that scale, the wall would need to be 100 kilometers wide to be visible. The myth originated in 1904, well before space travel, when William Stuckley wrote the wall was visible from the Moon with no basis whatsoever. That's the Great Wall from space, not a testament to human visibility, but evidence that even our grandest constructions are geologically insignificant. Number 8. Black holes are cosmic vacuums that suck everything in. Imagine a gravitational monster that pulls everything within reach into its maw, consuming stars and spacecraft with indiscriminate hunger. This is the black hole of popular imagination, a cosmic vacuum cleaner. Black holes do not suck. They don't pull or grab. They simply exist, warping space-time, and objects fall into them only if they get too close, exactly like any other massive object. If our sun suddenly became a black hole, nothing would change for Earth's orbit. We'd orbit the black hole exactly as we currently orbit the sun, at the same distance and speed. The gravitational influence would be identical because mass would be identical. What makes black holes special is density, all that mass compressed into a singularity. For a solar mass black hole, the event horizon has a radius of about 3 kilometers. Stay farther away, and the black hole behaves like any other object of equivalent mass. Black holes are remarkably inefficient at eating. Matter forms accretion disks, and much material is actually ejected in powerful jets. Stars orbit the supermassive black hole at our galaxy's center without being sucked in. They follow normal orbital mechanics. Black holes don't suck. They curve space-time intensely in a small region, and objects that wander too close follow those curves past the point of no return. Number 7. Stars twinkle. Because they're far away. Picture starlight dancing and shimmering, each point flickering like a candle. The twinkling of stars is so romantic that we've written poetry about it for millennia. Stars twinkle because they're far away, we're told. Distance causes the twinkle. Stars don't twinkle because they're far away. They twinkle because we're looking through turbulent air. Stellar light travels across space, perfectly stable for years or centuries. Then it hits Earth's atmosphere, gases with varying temperature and density. As light passes through these moving layers, it bends slightly. And because layers are in constant motion, the bending changes moment to moment. The proof? Planets don't twinkle, or twinkle far less. They present disks rather than points, so atmospheric turbulence affects different parts simultaneously, averaging out distortion. Stars appear as geometric points, making them vulnerable to atmospheric interference. Astronomers call this astronomical seeing, the primary limitation on telescope resolution. That's why we built Hubble, to get above the atmosphere entirely. Astronauts describe the strangeness of seeing stars from orbit. They don't twinkle, they burn steadily, somehow less alive. That's stellar twinkling. Not a property of distant stars, but a consequence of looking at stable cosmic light through turbulent atmosphere. Number 6. Astronauts float in space. Because there's no gravity, imagine the International Space Station where astronauts drift with effortless grace, freed from gravity's tyranny. This is zero gravity, a place where gravity no longer exists. Every report describes astronauts escaping Earth's gravity. Gravity at ISS altitude is approximately 90% as strong as Earth's surface. The astronauts are falling constantly. Earth's gravitational pull at 400 kilometers altitude is only 10% weaker than at sea level. If you stood on a platform there, you'd weigh only slightly less. Gravity is still present, pulling with nearly full force. So why float? Because they're in continuous freefall. The ISS falls toward Earth constantly, but it's moving forward at 7.66 kilometers per second. At that speed, the rate it falls toward Earth matches the rate Earth's curved surface falls away. The station keeps missing Earth, which is precisely what an orbit is. Inside, everything falls together. Walls, equipment, astronauts. When everything falls at the same rate, nothing appears to fall relative to anything else. That's weightlessness, not absent gravity, but absent resistance to gravity. The term zero-G is a misnomer. You never escape Earth's gravity anywhere in the solar system. The Moon, 384,400 kilometers away, is still bound by Earth's gravity. Astronauts float not because gravity is absent, but because they're falling at the same rate as everything around them. Number 5. Mars is red because of iron rust. Picture the red planet, a rusty desert world coated in oxidized iron like an ancient planet-sized shipwreck. Mars is red because its surface is literally rusted iron, we're told. This is mostly true, but how that rust formed is fundamentally wrong. Mars's surface contains substantial iron oxide, 15 to 17% by weight. But we say Mars rusted, implying the same process that turns wet nails red on Earth, iron exposed to water and oxygen. Mars lost most surface water billions of years ago, long before global reddening occurred. Current theory suggests Mars's color comes from photooxidation, UV radiation, breaking down iron-bearing minerals. UV light provides energy to transform ferrous iron into ferric iron oxide without requiring liquid water. This process took billions of years, but Mars has had billions of years. Additionally, Martian winds grind surface rocks into dust grains under 3 micrometers. These tiny particles scatter light, making dust appear more intensely red than the rocks it came from. Global dust storms coat everything in red powder. Early Mars may have been blue and white, water and ice visible from space. As the atmosphere escaped, the surface dried and gradually oxidized red over geological time. Mars is red, yes, but the planet didn't rust in any familiar sense. It was slowly colored by billions of years of sunlight and dust storms. Number 4, a year in space is shorter because time moves faster. Imagine astronauts experiencing time dilation, aging slower than Earth-bound people. When Scott Kelly returned from his year-long ISS stay, headlines proclaimed he'd traveled into the future, aged milliseconds less than his twin. The implication? Time moved faster for the orbiting astronaut. Time moved slower for the astronaut, not faster. His year was shorter, not longer. Einstein's relativity predicts moving clocks tick slower relative to stationary ones. After 1 year in orbit, Scott Kelly aged about 8.6 milliseconds less than if he'd remained on Earth. His clock accumulated fewer ticks. He lived through slightly less absolute time, meaning time moved slower for him. But gravitational time dilation complicates this. Time moves slower in stronger gravitational fields. On Earth's surface, we experience stronger gravity than astronauts at altitude. This makes time run faster for astronauts. The net result? Kelly still ages about 3.4 milliseconds less per year. For GPS satellites, which orbit higher, gravitational effects dominate. Time on GPS satellites runs 45 microseconds per day, faster than on Earth. Without correcting for both types of time dilation, GPS would accumulate 10-kilometer daily positioning errors. There is no universal now. Time is relative, frame-dependent, different for different observers. Your now and an astronaut's now are slightly different. A year in space is shorter than a year on Earth by milliseconds. Time moves slower for astronauts, not faster. Number 3. The North Star is the brightest star in the sky. Picture the one constant in northern skies, the star that guided explorers and escaped slaves, that anchored celestial navigation. Polaris, the North Star, so important we assume it must be brilliant, dominant. Surely importance correlates with brightness. Polaris isn't even in the top 40 brightest stars. It ranks approximately 48th, easily visible but unremarkable. The brightest star is Sirius, nearly 10 times brighter than Polaris. Canopus, Arcturus, Vega, Rigel, Betelgeuse, all blaze more brilliantly. Polaris is distinguished not by luminosity, but by position. It lies almost directly above Earth's North Pole, appearing nearly stationary while other stars rotate around it. That positional accident is the only reason Polaris matters. As Earth rotates, Polaris traces a tiny circle, essentially motionless. But this is temporary. Due to axial precession, Earth's rotational axis wobbles. Around 3000 BCE, Thuban was the North Star. By 14,000 CE, Vega will take the role. Polaris is actually a triple star system, a yellow supergiant 2,500 times more luminous than our Sun. If Polaris were at Sirius's distance, It would dominate Earth's sky like a second moon, but it lies 323 to 434 light-years away, far enough that intrinsic brilliance is reduced to ordinary brightness. Ancient navigators chose Polaris for reliability, not brightness. It offered certainty in rotating heavens, a fixed navigational anchor. That's Polaris, not the brightest star, but an average one that happens to align with Earth's axis during this particular 26,000-year cycle. Number 2. Sound can't travel in space. Imagine the silent cosmos, spacecraft exploding noiselessly, battles conducted in eerie quiet. This is the space of science fiction realism. We teach this as fundamental truth. Sound requires a medium. Space is vacuum. Therefore, sound cannot travel in space. The universe is silent. Sound can travel in space. It just can't travel very far, and you couldn't hear it without instruments. The interstellar medium contains approximately 1 atom per cubic centimeter. Sparse, but not nothing. Sound is a pressure wave propagating through matter. In principle, sound can travel through any medium with particles capable of transmitting vibration. NASA has recorded sound in space. In 2003, they released a recording from the Perseus galaxy cluster, a low B-flat, 57 octaves below middle C, created by pressure waves from a supermassive black hole traveling through diffuse hot gas for 2.5 billion years. These are fundamentally acoustic phenomena. The sun rings like a bell, vibrating with acoustic oscillations as internal pressure waves reflect off density layers. These helioseismic vibrations exist as standing waves throughout the solar interior. What is true? Sound can't travel efficiently through hard vacuum over useful distances. Observers in separate spacecraft wouldn't hear each other, but within structures, through thin gas, via solid connections, sound propagates fine in space environments. Space isn't silent. It's full of acoustic phenomena at frequencies and through media we can't directly perceive. We call it silent because we can't hear it. Sound can travel in space, just not efficiently, not in ways we can hear without instruments. But wherever matter exists, pressure waves propagate. Number 1. Stars look white because they're hot. Imagine looking up at thousands of stars, noticing different colors. Some reddish like Betelgeuse, some bluish like Rigel, most appearing white. We're taught star color indicates temperature. Red stars cool, white stars hot, blue stars hottest. So when we see predominantly white stars, the logical conclusion is most stars are hot white stars burning at 10,000 plus Kelvin. Except almost everything you're seeing is wrong. A perceptual illusion created by your eyes and brain. Most stars are actually red dwarfs, cool stars far dimmer than our sun, comprising 75% of all stars. But you can't see them with naked eyes because they're too dim. Even Proxima Centauri, the nearest star at 4.24 light-years, is invisible without telescopes. When you look up, you're seeing only the brightest stars, heavily biased toward intrinsically luminous types. But why do visible stars look white? Because your eyes are terrible at color perception under low light. Human vision uses cones for color, requiring bright light, and rods for low light, essentially monochrome. Stars emit so little light that you're seeing them primarily with rod cells. Rod vision is nearly colorless. We perceive most stars as white because color-detecting cones aren't receiving enough photons. Long-exposure astrophotography reveals the truth. Expose for several seconds to accumulate photons, and stars explode into color. Reds, oranges, yellows. Blues spread like a jewel box. These colors were always there. Your eyes just couldn't see them. Human color perception is relative, not absolute. Your brain automatically white balances, adjusting perceived color to make the brightest thing appear neutral. When you look at night sky, your brain calibrates white based on brightest stars, making everything appear relative to that arbitrary standard. The very concept of star color is observer-dependent. Different species would see different colors. A being with infrared vision would see cool red dwarfs as bright and hot blue stars as dim. When you look up at night, you're not seeing the universe. You're seeing a heavily filtered, perceptually distorted, biologically constrained approximation optimized by evolution to help you avoid predators, not to do astronomy. Every time you look up, you're experiencing the most fundamental cosmic deception. Thinking you see clearly when you're looking through biological limitations that transform cosmic reality into comfortable human fiction. That's the night sky, not a field of white stars, but a kaleidoscope of colors your eyes cannot see, filtered through atmospheric distortion and biological limitation. The universe doesn't lie to us. We lie to ourselves, projecting Earth logic onto cosmic scales. Space isn't what you think it is. It's stranger, emptier, more colorful, and more deceptive than the stories we tell to make it comprehensible. Look up tonight. The stars aren't twinkling because they're distant. They're twinkling because you're looking through weather. They aren't white because they're hot. They're white because your eyes are broken by design. And that North Star? It's not particularly bright, just convenient, temporarily aligned with a wobbling planet's axis. Nothing in space is what it seems. And that, more than anything, is the truest thing about the universe.